Let us look at addition and subtraction of vectors. Remember, in the last class, we talked about representing vectors using lines and columns. If I do something like this can represent a vector, and I can decide to represent the vector using the column vector x, y. Today, we'll look at addition and subtraction of vectors. So let's say I ask you to calculate -5 minus 4. What are you going to tell me about this? So -5 minus 4, we will talk about how this relates to vectors. You know, you can tell me your answer to this is just simply what? -1. Because -5 minus becomes plus. So when you add -5 to 4, you will be getting -1. So look at this. The vector GH is -5 and 6. It says work out 3GH. For this is just a scalar multiplication. So when you say you want to find the vector 3 times -5 and 6, then this vector will result into -15, and then you have 6 times 3, that is 18, as simple as that. So if I ask you to work out these vectors, work out this vector and this vector by addition, all you need to do is to add the corresponding entries. So you have 3 plus -1, that is what? 3 minus 1. And 3 minus 1 is 2. Now you have -2 plus -6. Remember, the plus times this minus is going to give you minus. So -2 minus 6 is -8. Now, it says I should write as a column vector, the vector A. Now, look at this vector A. What is going to be the column vector of this? Remember, this is the starting point because your arrow is facing this way. So you count 1, 2, 3, 4. There is 4 movements to the left, meaning that your x-axis is going to be -4 for left. How many movements up? 1, 2, 3. 3 movements up, so that would be 3. So this is the column vector. As you can see, this is your answer. 2 and -8 and -4, 3, as you can see. Now, draw the vector -a. This vector has the same size, but the direction is opposite. So when you have a vector A in this direction, and I ask you to draw a vector -a, it means that you are having the same magnitude, but the direction will just be opposite, just as you can see in this. So right now, I want to quickly talk about the magnitude of a vector. When you have a vector, the magnitude of a vector, so magnitude of vector A, for instance, will be the square root of x squared plus y squared. So you put your vector in column as a column vector. Let's assume I want to find the magnitude of A. In this case, the magnitude of A will be equal to the square root of the square of this plus, remember, put this in parentheses, the square of 3. And what would this be? The square root of 4 is 16. The square root of 3 is 9. And when you add this up, you get the square root of 25, which eventually is what? 5. So this is the magnitude of the vector A. Also remember, sometimes it is possible that a vector might have a negative number. So let's say I have the vector A is -2, and then I have 5. If I have to find the magnitude of A, what will happen? This will be the square root of, this is why I said you should always put the number in parentheses. The x is what? -2 squared plus the y 5 squared. And this will be the square root of what? 4, because minus 2 squared simply means minus 2 times minus 2. And then the minus times the minus is a plus. The 2 times the 2 is a 4. Therefore, this will be 25. And when you find that addition, you have the square root of 29. So let's go to the next. Combining vectors in a triangle. So let's say I have this. If this is a triangle A, B, C, as you can see, from my A to B, look at the direction. From C to B, look at the direction. And from A to C, look at the direction. So there is a movement, there's a journey from A going to C, and the journey continues from C going to B. And this is coming opposites. Therefore, what is important? If I give you a triangle A, B, C, and I tell you that this represents A, this represents B, if I ask you to find BC, the vector BC, what are you going to do? Let's go back. What is the journey? You start your journey, as you can see, from B to A. So B, the vector BA plus, the journey continues again from A to C, AC, and this is equal to, the one that is coming in opposite direction is what? Vector BC. Therefore, it means that the vector BC will be equal to A plus B. So let's move on. Calculate. Look at this vector. But what are you going to calculate? Let's assume I ask you to calculate A minus B. What will this be? Combine this. As you can see. So what will be A minus B? What is the column vector for A? You have it to be this. What is the column vector for B? You also have it to be this. If you subtract this from this, you will get what? This vector. So what is the direction? Let's get to questions that will reflect exam techniques. For this ones, it says find the column vector. You really don't need to do much in all these ones. Still pretty the same thing that we've been talking about. Exam techniques. Look at this question. It says the vector mn equals 3, 1. Decide in each case whether mn and p are collinear. Give a reason for your answer. So I'm going to give you a quick tip right now. And what is that tip? Two vectors are collinear if they lie on a straight line. That is, one vector is a multiple of the other. So, for example, if I have the vector PQ to be 3, 2. And I have the vector PR to be 18, 12. What do you notice? That the vector PR is a multiple. But what kind of multiple? A multiple of the vector what? PQ. Because if you multiply vector PQ by 6, you will get vector PR. Therefore, you can say that the vectors are collinear. Also, if I ask you for parallel vectors, if I tell you to show whether two vectors are parallel, one of the vectors must be written as a multiple of the other vectors. So therefore, what do we do right now? It says decide in each case whether MN and P are collinear. Since your MN is 3, 1, and your MP is 9, 3. Yes, they are collinear. And what is the reason? Because MP is a multiple of MN. It's as simple as that. So I'll leave you to do the rest and comment on the section below. Let's look at another technique. The question, number 5, says EDG is a triangle where DE is 4A and DG is 6B. N is a point on DG such that DN ratio NG is 3 to 1. So look at this. On this line, N is a point on this line such that the line has 4 parts. From D to N, it takes 3 parts. And from N to G takes just 1 part. That's the meaning. Ratios. Now, write NG, the vector NG in terms of B. Don't forget, the vector DG is 6B, meaning that to get the vector N to G, that is just 1 part out of 4, which is the total part that the line is divided into. Multiply by 6B, which is the entire vector. And if you do this calculation, you will be getting 3 over 2B. That is the vector NG in terms of B. Write the vector GM in terms of A and B. Remember, if I draw out that, I'm going to explain this properly so that you understand. This is D, this is G, and this is E. Now, vector D to E is 4A. Vector D to G is 6B. Before you do anything, you need to find this vector, vector G to E. So for me to find G to E, what do I need to do? Remember, the vector is just like a journey. So if you're moving from this journey, from where? From D, as you can see, you can continue because this is going in this direction. So vector DG plus vector GE must be equal to vector DE, which is coming in opposite direction. Therefore, the vector GE is equal to the vector DE minus the vector DG. And you can as well say this is 4A minus 6B. So that's the entire side. Now, we want to write vector GM. But they said vector M, the point M is the midpoint of GE. It means that this vector GM will be exactly half of vector GE, which is 4A minus 6B divided by 2. It is important for you to simplify this. As you can see, this is the same as 2A minus 3B. This is the answer to this question. So when you see questions like this in exams, you should be able to answer this question. I'll leave you to do the other questions, and then you can post your answers in the comment section. Okay. Bye for now.